Good afternoon, everyone. Welcome, welcome, welcome. Okay, so welcome again. This is Artemis Learning Pathway, um, and we're looking at Artemis future missions. And, we're so excited to celebrate the launch of Artemis 1, which is the first in a series of increasingly complex missions that will enable human exploration to the moon, Mars, and beyond. And my name is Latina Taylor. I am a NASA EPDC education specialist with NASA EPDC over at Texas State University. And tomorrow morning, hope you can join us at 10 a.m. Eastern Standard Time. We will facilitate our live student family engagement event that's connected to this evening's webinar. So you guys will get a preview as to what we will be, facilitating tomorrow with students. And we want to encourage all grade levels from kindergarten and up, college and so forth. And so you are all encouraged to log in and learn more about NASA's Artemis missions to the moon and Mars, and like I said, beyond. And so the first question, now we're going to put our student hat on. And the first question I want to pose to the students would be, what do you know about NASA? And I have this question there, hugely because I've been going into schools. I'm in schools like two to three times a week, and what I'm learning is that kids know very little about NASA, but some know some. They know some things. So you want to definitely build on what students already know, what they bring to the table. So to do that, I would love for you guys to share your thoughts, again, when you're in the role of a student. And we're going to be using a platform to do that. We're going to document our learning with a very user-friendly and extremely easy to use free tool called Padlet. Padlet allows learners to collaborate online by posting text, images, links, documents, videos, voice recordings. It's a really amazing tool. So what we're going to do is, as you can see, this is a screenshot of it, and I'm going to put the link to the page that I created for Padlet for us to document our learning in the chat box. And then you can click on that link. There it is, put it here. Here we go. And the first, if you look at, if we're going to read it from, in my screen, well, I guess it's left to right, the first question I'm asking the whole group is, what do you know about NASA? And so, and this is what I'll be asking the kids to do tomorrow. And, you can either click on the link and go into the Padlet, or if you can't access the Padlet, have some issues with that, no problem. You can post your ideas right here in the chat box as well. So I want to give you guys a moment to kind of post some ideas. And how do you do that? You click here where it says add comment. This is a little screenshot of it. I can see some postings coming in already. Thank you. Anonymous says, NASA furthers our exploration and knowledge of space. Thank you. Thank you so much. Thank you for your post. Someone's saying a place that I would love to work. Okay, Anonymous. You can put your names if you like to put your name at the end. We'll love to hear, give you a personal shout out. And I'm looking over here at the chat box. It says, a great point. Most students know about rockets. Yes, and associated it to NASA, but absolutely need to build. Yes, they do need to build a deeper, more deeper understanding as to, what NASA does, and one way to do that is actually taking a look at the acronym, right? National Aeronautics and Space Administration. So, that aeronautics piece, and going into depth about that. NASA's place is the Space and Aeronautics Organization and all things space and STEM related. Thank you, Amy. Welcome. So thank you, everyone. So thank you for taking a moment to just, again, to, pique our students' interest, right? To kind of, find out what they know, and that's activating that prior knowledge, right? And why do we do this? Why do we activate the prior knowledge? Well, students, there's research behind it. Students bring those funds of knowledge to the classroom, and oftentimes it includes their background knowledge, their experiences, the skill sets that they have just to navigate through their day. And so, when we capitalize, on that background knowledge, it's creating that optimal learning environment. And so, we definitely want to do that. So thank you for your participation with that. And so now, what we're going to do now is travel. We're going to travel back in time to July 20th, 1969. On this day, as you can see, headline in newspapers all over our country, was a historic moment in American history. Okay. So on July 20th, 1969, Commander Neil Armstrong, along with Command Module pilot Michael Collins and Module pilot Buzz Aldrin, or Edwin Buzz Aldrin, took the first small step for man and a giant leap for mankind when they walked on the moon. The primary objective of the Apollo 11 missions, or the Apollo missions in general, was a national goal that was set by President John F. Kennedy in 1961. And that goal was perform a lunar landing and return back home safely. And so an estimated 650 million people watched Armstrong's televised image and heard his voice, as he described the event. And so, he said, one small step for man, one giant leap for mankind. This is a link to that sound file where you can bring, those words, his words, to the classroom. But I even got a one above. I actually went and found, video footage. So we're going to look at a quick 30-second video of that historic moment. Let me mute myself.
Very fine grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the limb. That's one small step for man, one giant leap for mankind. Oh, that looks beautiful from here, Neil. It has a stark beauty all its own. It's
Okay, now back to the future. That was the past, now the future. The big question we say to the students is, did you know that we're going back to the moon? Let's check out the spacecraft and the amazing rocket that will get us there. Meet Orion. Orion, for the first time in a generation, NASA has built a human spacecraft designed for deep space missions. And it was named after one of the largest constellations in the night sky, and it's drawing on more than 50 years of space flight research and development. The Orion spacecraft is designed to meet the evolving needs of our nation's deep space exploration. I want you to know that Orion will be the exploration vehicle that will carry the crew to space, provide emergency abort capability, and sustain astronauts during their missions, and that will provide a safe re-entry to come back home. This module, the whole crew module, is designed to accommodate 99% of the human population. So, which is a larger range than any other NASA or Department of Defense project, the past, present, or future. The spacecraft can accommodate astronauts as small as a 4'10" female or as tall as a 6'5" male. And this module provides about 30% more cubic volume space than the Apollo module. The heat shield. Orion has the world's largest heat shield, literally. It measures about 16.5 feet in diameter. And has been successfully attached to the Orion spacecraft. And the heat shield is made of one single seamless piece of what we call avocat ablator, which was designed by Lockheed Martin. And this material is designed to burn away rather than transfer temperatures back to the Orion. And one interesting fact you want to know is that standing between the crew module and all that heat is no more than 1.66 inches of the avocat, which, as it's coming in back to Earth, back home, the avocat will erode about 20% during its journey back home to Earth. And the heat shield is actually going to withstand about 5,000 degrees Fahrenheit during re-entry, which is hot. Just how hot is 5,000 degrees Fahrenheit? Well, this is half the temperature of the sun. So it's hotter than the sun. And upon re-entry, Orion pushes air particles, out of its way. And those particles actually heat up. The temperatures turn around the vehicle to reach that heat that's coming in. So during re-entry, Orion is literally a fireball. And so, as it's coming in and speeding in, is actually jetting speeds at about 25,000 miles per hour. And as it's coming in, it's important to, kind of slow some of that speed down. And so, Orion has specially designed parachute system to help it, come in. It drops from 25,000 feet, as we're parachuting, to about 300 miles per hour, which is still too fast to land safely on the moon. In the ocean. And so then there's this whole second system that comes in, and another third system of parachutes that helps it calm down to about 20 miles per hour, which makes it very comfortable for the astronauts to have a nice splash landing, as we see here. And so that's what it's all about. Our astronauts going to the moon and coming back home safely, right? And so here's SLS, or the Space Launch System. Artemis missions will launch from NASA's modernized spaceport over at Kennedy Space Center in Florida on the agency's most powerful heavy lift rocket, Space Launch System, or SLS, designed for deep space missions, and it is the most powerful rocket in the whole world. Take a look at it. SLS has 4 main sections, and it stands about 400 feet tall. The upper stage is where Orion sits, right there on top. You see the white part. It will carry 4 astronauts to the moon, bring them back home safely. The orange area, that's the core stage. Well, that holds about 733,000 gallons of propellant, enough to power 4 RS-25 engines that will speed up at about 8 minutes, soaring to space at 17,000 miles per hour, which is pretty fast. So I definitely want to talk about how fast 17,000 miles per hour is with our students. And so those white solid boosters, those stand about 17 stories high, and they generate about 3.6 million pounds of thrust. And then you have your 4 engines at the bottom. So SLS is definitely a sight to see. And so one thing I want to know that we want to think about is, once our spacecraft are out there, traveling these far distances, Orion will travel 280,000 miles away from home. And so how does NASA communicate with faraway spacecraft? how does it communicate? And so that's one question that we will have the students to think about. So I'm going to put you back into the role of students here. I see in the Padlet we have some thoughts already. Thank you for those that are already thinking about the Padlet and putting things out. Someone said communication networks of different reach. Okay, thank you. And so if you can share your thoughts as to, again, how do you think NASA communicates with faraway spacecraft? We never know what students might, their ideas would be, right? And so it's so, important to for them to share their ideas, before, we tell them, because they might have an idea already. So it's really good to see some ideas. Jorge says the Deep Space Network. Thank you, Jorge. Yes, Deep Space Network, bridging satellites and networks. Yes. So let's take a look. Thank you for putting your ideas in the Padlet. And again, you can also put your ideas here in the chat box as well. So let's see. Let's talk about. Thank you, Jorge. You mentioned the Deep Space Network. So spacecraft send information and pictures back to Earth using NASA's Deep Space Network. Yes, which is a collection of big radio antennas. Okay. The antennas also receive details about where the spacecraft are and how they're doing. And NASA uses a Deep Space Network to send lists of instructions to the spacecraft. Wait a minute. Can you guys see my camera? I thought my camera was on. I'm sorry. I'm just noticing it said start sharing. I thought I shared it already. Okay, it's on. Thank you. Thank you, Pam. And so the question is, I just talked about that. So now a little bit more about the Deep Space Network. So those three big antennas that we talked about are evenly spaced around the world. I'm gonna go back to this picture again so you kind of see this. They're evenly spaced around the world. One is in California, one is in Spain, and the other one is in Australia. That means literally as the world is turning, these antennas are connecting, and it can always contact the spacecraft no matter where they are in the sky above Earth. And so these facilities are approximately 120 degrees degrees apart from each other, longitude around the world. And so this whole strategic placement allows and permits communication with spacecraft as our planet rotates. Okay. A little bit more about the Deep Space Network. When it comes to making a long distance phone call, it's hard to top NASA's Deep Space Network. It is the largest, most sensitive telecommunication system in the world. This international array of antennas, giant antennas, support interplanetary spacecraft missions, plus a few that orbit our Earth. And I'm going to talk to you a little bit about telerobotics. Telerobotics is a special field that studies, actually within robotics, that uses the NASA's Deep Space Networks to remotely control a variety of robotic arms, rovers, and other devices. Telerobotics actually makes it possible for NASA to take dangerous or long duration tasks out of the hands of humans, and helps to speed up human space exploration missions to new destinations. So one example of telerobotics is the exploration of Mars, of the surface of Mars, with rovers like Curiosity, Perseverance that you see here. They're all programmed remotely from Earth. Other planets are studied from space by robotic satellites, like you see the Cassini spacecraft here, which orbits Saturn. Both rovers and satellites have computers on board, and they're able to receive and execute commands right here from home, from Earth. And all of these missions are constantly sending data to and from scientists back on Earth. And how does this work? It all works thanks to NASA's Deep Space Network. This is a really great video that I'm definitely going to show tomorrow so that it can help kids to wrap their minds around how the Deep Space Network works. So let's take a look at this video.
How do scientists and engineers communicate with faraway robotic spacecraft exploring our solar system? When scientists and engineers want to send commands to a spacecraft, they turn to the Deep Space Network, NASA's international array of giant radio antennas used to communicate with spacecraft at the moon and beyond. Operators at the Deep Space Network take commands, break them into digital bits, precisely aim these big antennas at the spacecraft, and send those commands to the spacecraft using radio waves. But what are radio waves really? Well, to start with, you probably already know they're part of the electromagnetic spectrum, which includes other kinds of waves and light that you're familiar with. Electromagnetic energy is a type of energy that can travel through space as waves that have different properties, depending on the size and spacing of the waves. These waves span a broad spectrum, from very long radio waves to very short gamma rays. The human eye can detect only a small portion of this spectrum, which is why it's called visible light. Radio waves are the longest in the electromagnetic spectrum, and the wavelengths used by the Deep Space Network currently range from about the size of a dime to the size of a dollar bill. Radio waves are all around us. We use them when we listen to music over the radio, or send emails from computers using Wi-Fi, or when we talk on cell phones. Computers and cell phones are actually just high-tech radios. Radio waves also travel really, really fast, at the speed of light. That's 186,000 miles per second. But our solar system is also really, really big. It could take several minutes or even hours for the radio waves to reach a spacecraft. Once spacecraft receive the signal, they execute commands, collect scientific data and never-before-seen images, and send all of that data back to Earth as digital bits, which are gathered by the huge antennas of the Deep Space Network and distributed to scientists, allowing them to learn a little bit more about how our solar system works. To learn more about the Deep Space Network, visit go.nasa.gov/about-dsn.
All right, let's see. So that video, an amazing video. This one here, also really great. I'm not going to show it, but this is like a virtual tour of the Deep Space Network system. And so really great video there. So you can share that with students as well. If you want to know more, you want kids to go deeper and do some more research, this is a really, really great website. This is Space Communication and Navigation. This is your one-stop shop for everything Deep Space Network. It talks about the scan, technology and engineering, ideas. You can click on the links there, and much, much, much more. It has videos, images, interesting facts, live data. And speaking of live data, take a look at this. I'm going to put this in the chat box. This is Deep Space Network Now. This is the current live data of the Deep Space Network, where you can see, what's happening now, where are the antennas positioned, really give the kids, a real world picture. I'm going to put that in the chat box. You can kind of take a look at it. And the data is updated every 5 seconds. And so, that you get to see, again, what those antennas are picking up, what's happening, the whole shebang. So take a look at that. It's, again, really, really great site. at the end of today's webinar, you will be able to download a PDF version of today's slide deck presentation. So you'll get a chance to get this whole PowerPoint, as well as all these documents that you see here. Additional resources, web links, documents. I have some lithographs on the Deep Space Network and antennas, so you can get a chance to, the kids can download those and kind of read about them, in addition to some additional Artemis Learning Pathways resources, for a chance for you to sign up to receive, more information about the Artemis 1 launch, in addition to, what's going on, all updates with Artemis. And so, and you also have the Deep Space Communication Educator Guide, the one that we will be, kind of going over today. So Artemis, as you can see, we're going back to the moon. And it's through the Artemis program. Artemis is an ongoing space mission that's currently being run by NASA with the goal of landing the first female astronaut and the first astronaut of color on the moon's south pole by the end of this decade. If you know a little bit about Greek mythology, we had the Apollo missions, and Apollo was the god of the sun. And so what you probably didn't know is that Apollo had a twin sister, Artemis. And it's so fitting because Artemis is the goddess of the moon, okay, and the goddess of hunt. And so, Artemis, this whole Artemis mission, is the torch bringer, personifying our pathway back to the moon. During this next era of human exploration, we will discover life-saving, earth-changing science and innovative technologies along the way. We haven't gone to the moon since Apollo 17, and that was in 1972. So that was over 50 years ago. And, NASA intends to launch future missions to Mars. Okay, this whole moon to Mars plan involves building a brand new space station in lunar orbit that will, that we call the Gateway. Here's the Gateway, and eventually a habitable moon base. And a little bit about Gateway. The Gateway will be an outpost, orbiting the moon and providing vital support along, the support for long-term human missions to the lunar surface, and a staging point for deep space exploration. Much like the International Space Station, which has been in operation for more than over 20 years, the Gateway, and it's actually, International Space Station serves as a huge model, for the Gateway. And the Gateway will be constructed with the help of our international partners, several of which they have already expressed, high interest in participating. We have the European Space Agency, Canada, Japan, all committing to join in the creation and the use of the Gateway. And it's also important to note that every NASA center is contributing to the Artemis mission. So we're going to here. This is a trajectory of what it looks like, or a pathway to back to the lunar surface. SLS and Orion, they're part of this larger campaign, which is our first phase, and so we have Artemis 1. Artemis 1 is set to launch this year, 2022. We don't have the date yet, but it's 2022. It's happening. And Artemis 1 will be, an uncrewed flight, so no astronauts on board. And it will be the first integrated test of NASA's Orion spacecraft, SLS rocket, the ground systems at Kennedy Space Center at Cape Canaveral, Florida. And during this flight, the spacecraft will launch, again, on the world's most powerful rocket, and will fly farther than we ever have gone before, traveling more than 280,000 miles from home. And it's going to take about 3 weeks, for this mission. And Orion will stay longer than any spaceship has, ever done. and then it's going to return home faster and hotter than ever before. And coming back, it's all about testing the technology, making sure everything works, which is a part of the engineering design process, right? Test it out, see what's working, see what's not working, and make adjustments if needed. And so now Artemis future missions, right? So that's Artemis 1, which is happening 2022. It's incredible, right? So now future missions. And I want you to think about this. This is where I have the students to think about, what do you know? Or what do you want to know? What do you want to know about Artemis future missions? And so I see that you can put it in the chat box, or you can go back to the Padlet, but I see some things are already on here. What do you want to know about the future missions? What do you want to know? I'm gonna give you guys a moment to kind of think about that. What do you want to know? Here it says when current technology will be implemented into Artemis, or how much of the current technology is already in Artemis. We say current technology. I wonder, what does that mean? What current technology is in use? When we get to Mars, how will it be after it's over? Will there be a permanent station on the moon, or more space stations to progress? Very good question. Very good question. What else? Any other thoughts? What else do you guys want to know about the future missions? Any other thoughts? What is the plan for Artemis 2 and 3? Will they be staggered a few years after 1? Very good question. Very good question. Let's get into it. Somebody said, I want to know, will people be able to experience life at the stations? Do you mean on the moon or station, or on the gateway station? So tell me, I would love to know a little bit more about what do you mean? Will active experiments be going on? Great question. How will they be bringing and creating enough food? Yeah, enough food for the 2-year mission to Mars. We have to eat, right? Actually, it takes 7 months to travel from the Earth to Mars. So I'm wondering myself, how will we survive in this capsule? How will we be able to eat? I know that they have been growing food on the International Space Station, so maybe some of those lessons learned will be able to, do or replicate some of those things, as we travel to Mars. So those are some really great questions. These are really great things you want to know. Let's find out more about future missions. And so thank you for participating in that Padlet post. Artemis 2. Now, Artemis 1, as we saw, was the uncrewed flight. Artemis 2 will be a crewed lunar flyby. Okay, a flyby. The first human missions to the moon in the 21st century aboard SLS and Orion spacecraft. On this 10-day crewed flight, NASA astronauts will set the record. They're going to set a record for the furthest human travel from Earth, which is huge. With up to 4 astronauts in tow, we will return to the lunar environment for the first time in more than 50 years. 50 years. It will be the Artemis generation's Apollo 8 moment. And I'm air quoting those. This is when those astronauts aboard Orion will capture a full globe of the Earth from afar, and as a backdrop of the moon, and then be able to come back home safely. NASA's first missions with crew will mark a significant step forward in NASA's plans to return humans to the moon for long-term exploration and future missions to other worlds, including Mars and beyond. And so, when we are aboard this Artemis 2 mission, the astronauts will be validating, our deep space communication systems, and the navigation systems, and they're going to ensure all their life support systems and everything is keeping them safe and sound. So again, it's all about testing, making sure that they're going to be safe. How brave are these astronauts to do this, right? They'll be using Orion's light control and shading systems to simulate nighttime. So proper circadian rhythm, is happening during these missions. And this is a photo of the astronauts as they are training in the Orion mock-up over at NASA Johnson Space Center. Take a look at the Artemis crew. This is the Artemis crew. And I'm also going to put a link here in the chat box where you can even go and meet the Artemis team up close even more. In the lobby earlier, I shared a really great video where we met astronaut Victor Glover and his story. So take a look at that link there. But NASA selected an initial group of astronauts to help pave the way to our lunar missions, including the first woman and the first person of color that will walk on the lunar surface. So one of those will be, those historic astronauts, right? They're chosen from a wide, diverse range, of skill sets. We're talking medical doctors, marine biologists, geologists, submarine officers, test pilots. They have so many different careers and so many different skill sets. One question I will ask the students is, why do you think we need a medical doctor, aboard the Artemis crew? Why do we need a medical doctor, to be, part of that crew? And so, these, astronauts, have been training, for many years. And when once you click on that link and do some more exploration, have your students explore, you will see that they are ready and they are going. And so Artemis 3, now think about this, with all this confidence that we've gained from Artemis 1 and Artemis 2, right? The crew will once again aboard Orion and SLS and travel to the moon. But this time, they're going, as they get to the moon, they're going to board the human landing system. The human landing system that will bring the first woman and the first person of color to the moon surface, right? And I just wonder, what will their first words be? We had the one small step for man, one giant leap for mankind. I wonder, and all this is going to happen by the end of this decade. By the end of this decade, 2020 was the beginning of our decade, so the end is 2030. So before 2030, we will be a part of the Artemis generation. We are the Artemis generation, and we're going to get a chance to see, and be a part of this. As somebody said in the chat, exciting times. This is exciting times. And so 2 astronauts will, aboard the human landing system, which will carry them. And the human landing system will be definitely attached to the gateway, right? Because the gateway is going to be up there and established. Because again, that's our, our outposts that's going to help us go, travel back and forth from the moon to the surface. And so this human landing system will have 2 astronauts aboard and will carry them to the lunar South Pole with science tools and equipment. They will be there they will live, in that cabin for about 6.5 days, where there's food there, things that they need, sleeping facilities. They'll conduct about 4 moonwalks. They're going to capture, take a lot of samples, that they can collect and bring them back, to Earth for later research. Just going to the moon is just, it's a huge treasure trove of science, right? And so, as we continue to go back and forth, then we're going to establish the Artemis Base Camp, right? There's going to be an Artemis Base Camp. So what will they do? What will the Artemis crew do when they're on the moon? Well, first of all, they're going to search for the water, because if you don't know that there's water ice has been discovered, on the south poles of the moon. And so, we're going to send our robotic explorers to kind of go first. A robotic explorer called Viper will go and find the water, and then send us a map. And so the astronauts will find the water, search for it, study the moon and its discoveries, learn how to live and work on another celestial body, a whole nother planet. Where Earth, in this case, is just 3 days away. We're 3 days away from home, and then test all these new technologies and spacesuits, and then discover more of the moon than we've ever did before, with these vehicles. Take a look at that pressurized rover there. That rover, you can live on that rover for about 45 days. It has food, bedding, bathroom, and you can go and discover more. More. This is seeing more of the moon than we did with the Apollo missions. And so, so having that base camp and building this base camp and living and working on the moon is all preparing us to get to Mars. So everything that we do and we learn in the Artemis missions will pave our way for human missions to Mars. And I want you to think about this. The students in our classrooms today, those kids, they are our Artemis generation, right? We are the Artemis generation. They are our next generation of innovators, explorers, scientists, technologists, engineers, mathematicians, fashion designers, whatever. They are the ones that will be developing these new technologies, right? These new technologies that will help propel us to Mars and beyond. And thinking about Mars, going to Mars will not be easy. At its closest, it's 39 million miles away from home, from Earth, and a round trip distance will be about 2,000 times as far as a round trip to the moon. Okay, and so earlier someone said it takes about 2 to 3 years for that back forth, or that round trip. So what we learn from Artemis and our Martian robots, because we got robots that are there, and they actually call it bots before boots. And so our bots are there already collecting so much data, so much information, will help pave the way for our missions to Mars. And, maybe our students that's sitting in front of us, maybe one of them will be one of the first astronauts that will go to Mars. So kind of think about that as we look at our plans, NASA's plans to travel to the moon and to Mars and beyond. Let's play this quick video.
Three, 2, 1, 0. Ignition, liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust, provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program, and there are companies all across our country that have a part in it, so there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then, Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway land on the surface of the moon.
We are there for, weeks, months on end. And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there within the next couple of decades.
This also is another video. It's about 8 minutes, and it's a really great video that talks about the first Artemis mission, but then pushing into deeper space. So this was a really good one as well that you can share with your students. And so if you haven't already done so, please add to the Padlet. We'd love to know, what have you learned? What have you learned about Artemis future missions? We'd love to see your ideas on that. If you can put some thoughts into the Padlet, we'd love to know. What do you tell students when they ask, why does NASA want to go to the moon? Do you know what I tell them? This is what I say, because I actually get that. Like, why I get the question a lot as to, why do we go to space, or why do we do this? Like, why do we do it? Why? Because we, as humans, we're naturally curious. We want to know what's out there. So we're natural explorers. We're naturally inventors. We're naturally curious and want to be able to share that information. And going to the moon, and then on to Mars and beyond, is a part of that innate sense that we have built in us, to want to be these explorers. And so that's what I tell them. Why the moon? One big reason why the moon is because it's, as I said earlier, is a treasure trove of science. There's so much to learn there, and discover. And we have the technology and for 50 years of experience, from our, say, forefathers, to build on that and explore more this phenomenon that we look at every day as it changes different forms and different phases, right? So it's piquing that natural curiosity to want to know more. And I hope I answered your question, Laurie. And thank you for that question. That's amazing, because I get that question a lot. Okay, these are some additional resources. You want to know more about exploring a moon to the moon and Mars? When you go to this site in particular, you look down here where I put the red arrow. Click on that Artemis 1. You'll get all the updates. You'll know everything about that upcoming Artemis 1 launch. So definitely check out that site. And then let's take a look at the student learning goal for the activity. Here, when we talk about student learning goals, goals, make it easier, and it gives students an opportunity to think, and talk about what they learn. So I always, tell kids, this is our goal for today, so they can kind of know that, oh, this is what we're going to be learning about. And it makes it easier for them to basically know what they know. And it gives them a way to communicate what they know to others. And so here, we want to help students make sense, make sense of concepts like communication, because that's what this particular educator guide is all about. Latency, performance, and networking. For this particular activity, we're going to focus on networking. What does that mean in the context of NASA's deep space networks? And we want to help students to make sense and interpret astronomical phenomenon. phenomenon that they might read about in the news or see on the internet or look up on YouTube, because new discoveries in astronomy are a part of our everyday world. And when we talk about phenomenon, this is, what is it? Well, basically, a scientific phenomenon is an observable event. And it's, and in the classroom, the science classroom, a carefully chosen phenomenon, it can help drive that inquiry. When we talk about inquiry, I give it a visual. I see students asking questions and then students seeking answers to those questions. And so, it is the phenomenon plus the student, driven questions about the phenomenon that drives that instruction or that teaching. And so if you want to know more about phenomenon teaching, you can definitely check out that link, The Wonder of Science /phenomenon. It's an amazing site. We can go more in depth about phenomenon teaching. This particular educator guide hones in on the 5E instructional model. So you won't be using the engineering design process for this particular educator guide, but it focuses on the engagement, right? When we talk about the 5E instructional model, it's that inquiry base. Again, going back to those questions, the inquiry-based science instruction, where it's about enhancing students' understanding of science concepts, as they're increasing their interest in a field. And it has that constructivist learning cycle piece to it. So let's talk a little bit about engage. So engage, this is like the opening activity, to kind of get kids to, wrap their minds around, what's going on. And then this case, I kind of had an opening activity with the kids where we talked about, what do you know about NASA? In addition to this, what do you know about how, NASA communicates, with far away spacecraft. So kind of engaging them, or what is it that, finding out what they already know. You can use things like KWL charts. I love KWL charts because it reveals so much. And then the second one is explore. This is that hands-on piece, where students get to do those hands-on activities or experiments or, interact with materials to kind of deepen their understanding of content. And then you have explain. Once they've explored, then they attempt to explain, what they've learned or, from their experience. And then, again, I am kind of, summarizing them really quick. Let me go back. And then you have your elaborate. From explaining, students get a chance to elaborate on their understanding by applying what they've learned, to a new situation, basically to deepen their understanding. And elaborate is less about reading or watching or, videos or things like that, but it's all about making those connections. They're the concept to self, concept to concept, or concept to the world. And then after they elaborate, it's all about the evaluation, right? To get a chance to evaluate. Evaluate cannot simply mean vocabulary assessments or something like that, or graded journals. It now means reflecting, right? Reflecting critically. Or thinking about their process, their investigative process, or what was their hypothesis, and was it true or false, or so forth. And so it's all about that reflection piece. And so that's what this particular educator guide hones in on, and it also hones in on computational thinking. There's 7 core practices, with the K to 12 computational computer science framework. And so within this guide, 3 of them have been are focused on. So it's the first one fostering an inclusive computing culture, where this idea that everyone needs computers, but not everyone uses computers in the same way. Okay. And that idea of Inclusive computer culture requires people, like basically advocating for features and approaches to technology that makes it more accessible or accommodating, and then collaborating around computing. This is the idea that two heads are better than one, right? And then having that idea of mutual respect, when you are, working with computers, and then feedback that is constructive. And then the last one, communicating about computers, just knowing, what technology is the best to use and when you need to use it, and then being able to communicate, how to use the technology, or, putting out there, fair use and things like that. So for this particular educator guide, it focuses on those three strands. The Next Gen STEM has standards aligned activities to help students learn more about exploring the moon. As you can see, there's 6 of them. We're going to focus on the deep space communications, which you do have that link earlier in the chat. You can click on the educator guide and you'll be able to see it. This one in particular has 4 activities that basically, helps to build on students' understanding of communication. Okay, what communication is all about, such as we saw in the video: waves, speed of light, solar systems, and then networking. We will be taking a look at activity 4, which is all about networks and how networks work. For this particular activity, says learn how computers solve networking problems using minimum spanning trees. And we'll talk a little bit about spanning trees in a moment. And then they create a minimum spanning tree as a culmination of the activity. The educator guide is amazing. It has teacher pages. You should have probably already downloaded it and kind of check it out. It has student pages that students can follow along. Actually, I think I highlighted those student pages on here too. Yeah, the student pages as well. So educator guide plus the student pages and the teacher pages. The design challenges there, the objective process skills, the standards. I took a screenshot of that so you can see all the different standards, the national STEM standards, basically NGSS, ISTE, CSTA, and then the Common Core. And then also lets you know the suggesting pacing. For this particular activity, it takes about 45 to 60 minutes to complete. So it's a 1 hour activity. This matrix is amazing as well. It kind of lets you see out of the 4 activities within this guide, what standards are being targeted or are being met with each particular activity. And for this one, networks, you can see the science one, the technology piece, the engineering, and then the math. So the goal of this particular activity, students will solve a variety of network problems using minimum spanning trees. So this is, computer science stuff. And so they're basically determining the shortest route to visit each destination in a network. Okay. And so, I don't know what happened, but the screen should have more words to it, but that's okay. So when we talk about, because I'll fix that before I send it off to you guys. When we talk about minimum spanning trees, just quickly, it's basically a number of problems from graph theory, which is called minimum spanning trees problems. And so in graph theory, a tree is a way of connecting all the vertices together so that there's exactly one path from one vertex to another vertex of a tree. Excuse me. Excuse me. And so you can just see here on this example graph G, and then you can see how the vertices consist of 3 spanning trees, and each tree consisting of basically the equation n minus 1 times 3 minus 1 equals 2, the number of edges, which this is what, how this graph will come up with those 3 spanning trees. And so, and I just wanted to touch a little bit about the spanning trees. The design challenge here, for this particular activity, students need to find the most efficient way, to get from one place to another in a network. And one thing you want to do, and also it also has a career corner. I love that these student handouts, let's have it in my hand here, because you definitely want to print these out, and if you print out in color, that would be great, because there's, well, you could print it out in black and white, because they're going to be using color pencils, to make their routes, so to speak. So let's take a look at the materials. You need the student handouts, the scavenger hunts. One is a scavenger hunt, one is a deep space neighbors. A dry erase board will be nice with markers, colored pencils. Notice here, low cost, low budget materials, cotton swabs or toothpicks, which will help make those spanning trees. You could do buttons or pennies, so, very simple materials to help, implement this particular activity. The first thing you want to do is to engage. And how you engage them with this particular activity is to kind of ask them questions about, networks in the real world, because they're going to be making a network or connecting with networks, right? And so, what are some networks that are part of their daily lives? That's definitely something that I will ask them tomorrow. This is going to definitely be abbreviated from today. And thank you for staying a little bit extra now, just because I definitely want to talk a little more I wanted to talk to you about the activity. But we want to remind them, and I will probably remind them of different type of networks that are in their lives. I might say something like a phone network, and then maybe give them opportunity to come up with some different networks that they might, that are in their lives. It could be their class schedule. That's a network. Yeah. It could be transportation network, like, or their bus route. It could be navigating, going to the grocery store. Okay. So, we'll definitely have them make those real world connections with, networks in the real world. And then going to the actual challenge. The first challenge is this one, which is the doing the scavenger hunt. And so with this scavenger hunt, they'll be looking at this particular image. And they're going to be, there's 10 items here. So it says this scavenger hunt contains a list of items that you will need to find quickly. In this exercise, it's important to take as few steps as possible to locate all 10 items. In the diagram, you can see the map of the items, and the dash is connected to each item. Each dash represents a total of 20 steps. So they have to have 2 conditions. Okay, this is where that algebra, computer thinking comes in, right? The computational thinking. You must connect all the scavenger hunt items together with the path that you chose. That's one condition. The second is that you must take the least number of steps possible. And remember that each dash equals 20 steps. So if I was to start at the robot over here, the little blue and orange robot, and I'm looking for the shortest pathway, and again, the shortest steps, I might want to go to the astronauts, because I see, I only have 2 dashes there. So that's 40 steps. So then what's my next connection that maybe will get me to the fewest steps? I might go to the NASA meatball, so this is what they have to think. If I do this, those if and then statements, right? So that's that computer science, coming in at them, at whatever grade level. And so this scavenger hunt is that first activity. And I definitely will, have them, we will go in depth about that, and then have them to kind of post, how many steps did they take, to, complete their scavenger hunt with all 10 to get to all 10 items. And so, hopefully we'll get, get some really great numbers. So that's what it's going to kind of look like. I assume it doesn't have a matter. It doesn't have an order. So like, for example, here's some examples. So if you download the educator guide, you'll see some examples, some pathways to get to, all of the 10 items. And as a group, we'll come back and maybe, we'll have maybe some kids could share their pathways to get to the, all 10, with the least number. And, so we, having that group conversation after they do it individually, they kind of come up with their strategy and then come together to talk about it. So definitely we will get a lot of different responses. And you want to get a lot of different responses in this case, and that's a part of the challenge, right? These links down here, definitely check them out. One is a downlink. It's a Deep Space Network game, and I think the kids will get a kick out of that. And then Space Place, which tells us all about the Deep Space Network, but it's in kid-friendly language. The kids will love it. So those two links are incredible. And then the second activity, when we talk about elaborate, you want to show them something like this. This is also in the educator guide. I won't go into this because we won't have that much time to go into additional, but these are some additional activity that you can do with them after. To go into elaborate more, they can look more at this spanning tree, as well as the second challenge where they get a chance to do the deep space neighbors and take a look at that one, as well as then build their own spanning tree. So, it's definitely go in depth with that educator guide. And because I think that this is a really great opportunities for that to enhance that computational thinking, that critical thinking, and then the collaboration, definitely, where you can, after they do it individually, they can share with the partner, find out their partner's strategy. How did they, solve the problem? And it may be they find a new way from their partner on how, I could have took this route, things like that. So, looking forward to the opportunity for you guys to come and join in and bring your students in. I'm going to move us to the closeout because I want to go ahead and share. I'm going to put the Google link in here so you can access everything. I am going to add the PowerPoint right now, and then you will have that. Tomorrow at 10 a.m. Eastern Standard Time, we will go live with students. If you have not already done so, please register. I thought I have the link. Hold on, give me a second. I'll put the link in the chat box if you have not already done so. I'm also going to put the educator guide in the link here as well, so you can kind of take a look at that. But I'm going to put the link in here too. So if you have not already done so, please register and join us for future missions.